Hey engineers, today we are going to talk about the engineering notebook. And I actually have my engineering notebook right here, and we're going to talk about why engineers use this and why this is one of the most important things that you can have as an engineer. So let's dive right into it. The engineering notebook. We're going to talk about what it is, why should you keep one, who keeps one, what do you put in it, the different sections that it can include, the standard page layout, best practices. An engineering notebook, what it is, it's a book in which you formally document in chronological order, so in time order, all their work associated with a specific design project. I'm just going to show you mine right now just so you can kind of have an idea of what mine looks like. So I'm going to grab you here and follow me. So here's mine as you look down. Some friends of mine at NASA actually gave me this, so I wrote my name on it so you can see who it is. On the inside cover, I kind of have a table of contents. There's only one thing in here, but it was a pretty big project. It's the automated window blinds that are in the back of my classroom. So they start on page 4. So I'm going to flip. I numbered my pages down here, 1, 2, 3. I left a few blank, just I don't know why. But here's my automated window blinds. You can see like there's a sketch down here. This next page looks like some wiring diagrams. Like we used stepper motors. So how do we wire up a USB connector to the actual motor? Some other wiring. Some looks like a design for a mounting plate. Some other measurements that we had here. Some pictures. We reverse engineered actually one of the pulleys because we had this what's called a bead chain. So how do you have a gear that can wind up a bead chain? So we actually reverse engineered. This is a print off for our motors. It's got torque curves. So under how much torque do they have under how much speed? So you can kind of figure out how fast these can go, because you want them to go fast, but if they go too fast, they don't have enough force to pull the blinds up. This is some technical document. I glued these in. I used a glue stick to glue these things in. Here's a wiring diagram. Another mounting plate with some dimensions here. Just some other brainstorming things we had. We actually tried to figure out how much torque we needed to do this. We took a pull scale and we pulled up and we pulled down on the blinds to figure out how much force we needed. And then we coupled that with the radius of the tube. So then we figured out how much torque we actually needed. So then we could maximize how fast this thing goes. We figured out we needed 0.4 Newton meters of torque. Some other pictures of things. And that's it. That's the last page right there. So that's just kind of a quick and dirty tour through my engineering notebook. And we'll talk more about specifically and see if you can see some of the things that what we do with our engineering notebook inside of this. Why do we keep it? Probably the most important thing, it deals with capitalism. Like if in the United States, if you come up with a really good idea, you should be paid for it. And how do we prove someone's idea is whose? It's through an engineering notebook. We prove who came up with it, when they occurred, the diligence, like are you doing the actual math, because maybe you build something that breaks. You can prove that they did the math, that this should have worked. It wasn't an engineering fault. This was a manufacturing fault. Who did it? And then prove when an idea became a working solution. So when did it actually start working? Who uses this? Engineers who work on what's called R&D, and that stands for research and design. Also engineering students in high school and college. Some of the things that you'd put inside there. What is the problem? What research do you have? Like putting in, like you saw in mine, I put in pieces of paper that were wiring diagrams, torque curves, a picture of the original gear that we reverse engineered, sketches, so how much wire do we need to run from my control panel all the way over there, brainstorming ideas, any calculations that you have, daily thoughts or ideas, pictures, and basically it's everything. We actually had to have somebody come in from the university. We didn't know anything about stepper motors, so we brought in a professor to kind of help us, but they were lost too. Design modifications, testing, technical drawings, basically everything. Anything that you can put in there. Our table of contents. So typically in an engineering notebook, when you're doing this for a professional firm, if this ends up being what you do later in life, this is typically the way that it's laid out. There'll be something that says that this is proprietary information. My friends at NASA, they said that this engineering notebook, even though it says engineering notebook on there, the ones that they actually use are hardbound. They look like a book. It's got a hard cover, it's bound, and every time they get done with it, they just file it. So they have their entire life's work in all their sketches, everything that they've done for all of their projects that they keep in case they need to come back to it. Typically the inside, I don't know if you saw it, but it's got like a grid pattern on it. All of your pages are numbered and dated, and you sign it down here. You can see that it's signed by the user. There's the date. And then a witness, like typically it will be like a coworker, or it will be your boss. Page numbers. Everything that you do is in pen, and that's really important. And you might think to yourself, oh, I'm just sketching. But the thing about pencil is that you can erase it. The idea with pen is that this is proof that it was built, this was designed by me on this day. There's no way this could have gotten in there. Sometimes I only like to write on, you saw that when I was flipping pages, I was only writing on the right-hand side. I don't like to write on the back just in case it bleeds through. And the pages aren't able to be ripped out. Looking in mine, typically there's like a perforation. Ours don't have perforations, so you can't rip it out. So you can't insert or take out a piece of paper. So when you're finished, you'll notice that you start at the top and you start writing your way down, and then when you finish, you cross it off. So you'll see there's this strike through right here. Strike it so that nothing else can be added right there. If you do make an amendment, make sure that you just cross it off with a single line. Just a single line. You don't have to scribble it out, just a single line, and then write your correction above it. This way we can tell what they were thinking to begin with. They really thought it was Botox, but really it's borax. So you can see that the mistake or the edit was made, what the original was. Date each entry. And you'll see that this says 5/15. When you glue it, best practice would be gluing because it's permanent. Tape, you can, take things out, put things in. But there's a really clever way if you do tape something into your engineering notebook to prove that it was taped there by you. What you do is you sign across it. So you put a signature across something that you tape in there, so that way if it's removed, everything lines up perfectly. It's a way to tie the two things together. Someone should sign off as a witness on the bottom. Store it in a safe location. When you do your sketches, we're going to be doing a lot of sketches in our engineering notebooks throughout the year, just to kind of like, here's my idea. The more detailed you can be, the better. Label your parts. If you know diameters and radiuses and distances, the more detailed you can be up front, the better that your final product is going to be. Calculations or figures are clearly labeled. Reflection, like what would I do differently? Because maybe you come back to this years down the road. These blinds that I have in my classroom, we built those years ago, and if something goes wrong or should I want to improve them, I can't remember what we did back then. We're just going off of everything I have written down. Neat, accurate, legible, and thorough. Some examples from history. This is Earl Silas Tupper. Maybe you've heard of Tupperware. I'm sure your grandparents would if you ask them. This is his engineering notebook. Everett Huckley designs for an electromechanical fly catcher. Howard Head, 1914 and 1991. Maybe if you've seen, that's actually a brand name of tennis racket. This was his first tennis racket that wasn't wooden. No, portfolio. In closing, if there's one thing that I want you to learn from this class, and this is what engineering is, the only thing I would like you to learn from this class is to think before you act. And you'll get better at this because many times in this class I'm going to say build this, and it's really tempting to just run over to the parts and start building. And to give you kind of an example, when I was going through a training for this class, it was 2 weeks, 8 hours a day at the Milwaukee School of Engineering, and we were given this project where we had to build a marble sorter. So we had to take a cup of marbles, and they could be like metal or see-through or white or black or plastic. You had to pick 3 different kinds. You'd put them in there, and you had to pour it into the machine, and the machine had to sort them with 100% accuracy in 2 minutes, and you had to put at least 20 marbles in there. So my partner and I, and we were given 3 days, like a full 8 hours this day, 8 hours that day, 8 hours the third day, a full 24 hours to get this done. And my partner and I, we spent the entire first 8 hours brainstorming. We looked on the internet to see what has been out there, what sort of ideas people had before, what things we liked, what things we didn't like. We were sketching, we were being very specific. And I remember asking him, I was like, Ron, after the first day, everybody else had started building, and we literally wasted 8 hours, we thought it was wasted, thinking. And we started building the second day, and then we spent the entire second day and then half of our third day, and we had it done. And we were the first group to actually have a successful marble sorting machine. And I remember you had to have this done. You had to work. Otherwise, you wouldn't pass the class. And so I remember people on the third day, there's only 8 groups of people in this project. 2 of the 8 groups had disassembled everything and they had started over. And I was like, they literally wasted 2 full days, like 16 hours of work. They just disassembled and they started completely over. And I remember thinking to myself that 8 hours of thought up front prevented us from being one of those people. Some of these people stayed until 1 a.m. the third day. They kept working. And my friend Ron and I, we went sailing on Lake Michigan. Like, we took the other half of the day off, and I remember thinking to myself, from here on out, I'm really going to make a concerted effort when I build something to think up front, because it saves so much time in the back end. And I know, I'm telling you, you're probably going to rush into something the first time and you'll screw up, and then you'll think to yourself, man, I should have thought about that first. And that's the one thing I want you to get out of Principles of Engineering. Think before you start building. That's all engineering is. It's thinking first, building second. Have a great day, kids, and we'll talk to you later.